2008 Chevy Suburban, 1500, 5.3, two-wheel drive. Alternator is new because the voltmeter on the dashboard suddenly began to show 9 volts while driving and never recovered, and the battery finally went down to so low that the car could not be started or run. The alternator has a main 12-volt conductor that goes through the fuse on the firewall right there to the battery. Negative cable has the infamous current sensor. But what I want to show in this video is the signal that's on the gray wire that goes to the alternator from the either PCM or ECM, I don't know which, but that controls the stator field energization that tells the alternator how often to produce electric power. So I'll start the car. It's in working order now, so you'll see it charge up to above 14 volts. And now we can look at the duty cycle that's being commanded to the alternator, which is right here on the scope. Try to get it where it is in view. So if you can see that, that is 10 volts per division, 1 millisecond per division, and it's a nice square wave that goes, and now the duty cycle is the fraction, the ratio of how long it's high to the entire length of a cycle. So you can see right now the duty cycle is somewhere in the, it's either 50% or maybe about 30%. And the rail voltages on this line are 0 and battery voltage or charge voltage. They are not 0 and 5 volts. See what happened there? I lost my ground. Whenever I fix the ground, it'll go back nice. So you see, those that do arithmetic can confirm sorry, my ground keeps falling off. Those that do arithmetic can confirm that on a DC voltmeter, you're going to see roughly half of that high. So that'll be about 6 volts. And come over here and look at the DC voltmeter, and you see approximately that. So don't be fooled when you put a DC voltmeter on a wire. If that wire has a varying signal on it, you're going to be reading the average. If we change this to AC, you're going to see something different in that. And that has to do with the average of the swing. Between the two different voltages. So that's what normal looks like for the gray wire going into the alternator on one of these PCM commanded charging systems. Now we can switch over and look at the brown wire, and I don't know so much what it's supposed to do, but I can show you what the signal looks like. And there it is. Now we're on 5 volts per division, 5 milliseconds per division. And DC on the scope. Now it's I set the trying to change the time. Can't do it. So anyway, that's the brown wire. I don't really know what it does. But that's what it looks like under normal charging conditions. Look one more time at the volts. And depending on the duty cycle of the gray wire signal, you get either a lower or a higher voltage, as you've seen in the table that's published online. So I hope that helps. I've never seen it online, so here it is.